Okay, so where do we start? I think we have to start with understanding some technical practices and some principles that underlie the practices. Again, focusing on just common sense. How do we build software that allows us the ability to change? And there are a few simple principles in software development that are not very well known, but that address this. We call them the solid principles, SOLID, which is an acronym for these five principles. I just want to discuss two of them because I think the first two are the most important. And you'd be surprised at how powerful they are for cutting through, like poorly designed or poorly implemented systems and code. The first one, the S, stands for single responsibility. And this is of paramount importance when we think about building software because we want our software to be encapsulated. We don't want it sprawled out because it doesn't allow us to scale. So when we think about encapsulating each piece of behavior, we think about building models, which is what software is. So we think about building models that are responsible for their own little pieces and that we compose bigger systems from smaller systems that are, again, autonomous and well encapsulated. The way we do that is by hiding the behavior of components of our system in classes. So this is what object-oriented systems do and allows object-oriented systems to scale when we do it well. That's the idea. We want to make our systems responsible for themselves and make every piece of our system have just a single responsibility so that if something goes wrong, it's for the responsibility of that one single piece. And that means that all of our pieces are then isolated from each other so they can't interact. And that's really important because if pieces can interact, they can cause problems and we have to verify that they don't do that, which means that we have to write many, many tests for verification. So if we prevent them from being able to interact by isolating them in the first place, then we don't have to write tests to prove that they don't interact. You see, this is how it works. So what we're doing is we're modeling knowledge in such a way that it is most effective, that it is verifiable, and that it is extensible and modular. Those are the three virtues in my mind of good software. That it's modular, that it has pieces that can be interchanged, that it can be extended, and there are various ways of doing this in object-oriented systems, and that it can be verified independently, that we can write a good test to verify just its one single behavior. Yeah. And when software has those three virtues, I find that systems become composable and scalable. And so these are the secrets of building enterprise software. This is what the multi-million-dollar systems need to understand. And when we incorporate these concepts into our systems, we have scalable systems. It doesn't come from your organization. It doesn't come from making a better meeting. Scalable systems come from technical practices, from building systems with good technical practices.